Let's get started. So, in terms of smart built environments, what is the challenge first of all? Why do we need a definition? What's the point of it all? Well, the thing is, many people tend to use the term smart homes, buildings, cities to a point where we're in a situation where everything seems to be called smart now, and that's totally wrong. And we don't actually know what smart actually means in the context of a smart home, smart building, smart city, or smart environment, or any of those things. And how we understand what one is in relation to the technologies of the past as well as the future, so we can actually figure out how smart our environment might be in terms of some sort of maturity level. That's missing as well. And the term seems to be so extremely well abused enough for it to mean anything anyone wants it to mean, and seems to mean everything and nothing as well at the same time. And really what the smart built environment should mean something very specific, so that we know what we're talking about, and also to be able to exclude what we're not talking about. Right now it tends to include and exclude whatever any vendor definition wants it to. So in terms of that, what do smart technologies, do smart technologies make the smart built environment? And here we see a lot of people often talking about the fact that they've got technologies in their home, that they've got a smart home, and they take the idea of the technology making the home smart. And is it simple as that? If you buy smart technologies and stick them in your home, does that give you a smart home? Equally, there are plenty of buildings with smart technologies in them. Does that make a smart building smart if there's lots of technologies in them? Or does it just make a building with some very smart technologies in it? And that's the same that can be said of cities, because just because a city has a smart infrastructure or smart infrastructure projects, does that make the city a smart city? And equally the same can be applied to smart manufacturing environments as well. And some of the questions about smart devices and systems, you see, when you walk in a room and the light goes on, is that smart lighting? Or is that intelligent lighting? Or is that just automation? And the thing is, in many cases, people call it intelligent, and the intelligence they talk about is actually non-existent or very limited in many respects. It's just basically a simple level of automation, or just a couple of APIs to automate something. It doesn't make it smart, and it shouldn't necessarily be called smart. And that just begging the question, does automation make an environment smart? Absolutely not. And then what about multiple levels of automation? Do multiple levels of automation make something smart? Well, what about the intelligence and intelligent data collection? And often this is for the vendor, who will, they'll use it for intelligence, and that intelligence may not be equal in terms of the weight, the benefit, the weighting of the benefits the customer gets and the vendor gets. And where the data collection favours service providers or the vendor, that is not really counted, or should be counted, as benefit for other stakeholders. Remember, at the bottom line is automation is automation. It's not artificial intelligence, it's not big data analysis, it's not machine learning and all of that. And often these things are provided by smoke and mirrors where it doesn't actually exist. And the background to the definition I'll be covering and maturity indicators really is because the fact that we came across so many definitions of smart buildings, smart homes and smart cities, and they were calling themselves smart environments when in actual fact they weren't that smart. And the fact is that some of them were using the definitions with the aim of leaving out certain characteristics so that certain technologies could be excluded, or including things that shouldn't be included so that their technology could be included in it, and that was wrong as well. And we thought that shouldn't be the way that things work. And also there is a need for an independent definition which can provide a context of different technologies that exist and the relationships to those technologies. So we're going to start with definition, and we'll break it down to smaller components and look at the implications of all of those in a few more details. But before I do that, just a quick explanation. First of all, there are many definitions and they focus their context on benefits. And our view is that benefits alone or looking at benefits alone is deceptive, because in many cases in the so-called smart buildings and smart cities, it's possible to achieve the benefits that are being talked about whether or not you've got any technology is in place or not. Where then does that leave the environment as being called a smart environment if the benefits are there regardless of the technologies? So, you know, I do explore that in more detail. It won't be in this session, it's outside of here. I have looked at it in other presentations and covered it elsewhere. Next, in terms of the definition, just need to explain, it is the definition I'm providing, it is copyright of the company I work for, Virtually Informed. We developed it under Creative Commons license, and we are updating and we'll be providing a new version in Q1 next year. The current definition has been adopted by the IoT Security Foundation Smart Built Environment Group. It does include or it has been included rather, in 3 sets of guidance produced by the Smart Built Environment Group. There is work being done on the maturity models and the various levels, but the work for the model hasn't been completed at the moment, but we will provide that once that's available. Again, it will be under Creative Commons license, and you know, it's not being provided at the moment because it's not complete, but once it is, we will then go on from there and make it available to everyone. So, definition then. Smart built environment is one which utilizes several different sensor technologies to collect data, sharing it via a network to a unified management system to take actions or make decisions in order to provide benefits to various stakeholders. That is it in essence. But if we break it down, we get these 6 attributes. Firstly, it must connect to different technology systems. So a single system can't be a smart built environment. It must have several. Secondly, you know, sensors are usually the key part of it, whether it's a CCTV system, whether it's a burglar alarm, fire alarm, or detectors. There is some sort of sensor technology. Yes, there are also you know, IoT devices that don't actually use sensor technology, granted, but in terms of the smart built environment, majority of the devices will have some sort of sensor technology. Also, they are connected via a network, and that network has a unified management system that controls everything, and the aim is to take actions or to make decisions in order to provide benefits to stakeholders. There are the 6 attributes straight from definition. However, there's 2 key attributes that aren't in the definition at the moment, but we are looking at adding them in, and that will be the next version, and I'll cover that shortly. The first of the attributes, not in the definition, is the fact that the single unifying system only becomes smart when all relevant systems are connected together so that data from them can be used to make better benefit decisions. However, until that point, it's only really an environment that uses smart technologies. And this unifying system is what actually ties the management system and the decision-making intelligence together that make the overarching benefit decisions rather than isolated responses in an environment. Yeah. So they need to work together. That is key. Next thing, the whole technology that wraps around the environment, I appreciate it says building there, but the whole environment is secure so that it is able to function with the intended integrity, availability and confidentiality that is expected by all stakeholders. Essentially, the environment must be sustainable as a single unifying system. If it's not sustainable, it's not that smart either as a collection of devices or as a system or as a system of systems. That's the second key attribute, but we will be putting them into a definition at some point to be available early next year. Next, if we bring all that together, in the center you can say we've got the single unified system, and on the left we've got the sensors and all the sensing controls, the edge computing. This is all the hardware in many respects, and on the right hand side you've got the software and you've got the data and you've got the analysis, all of that thinking capability, and at the top you've got the governance of the systems, the data and the infrastructure, and when you bring them all together they'll all be resting on the security of the systems, the devices and the infrastructure. And if you take that and you wrap all of that together, what you then add to it is the trust in the security and privacy and the resilience of that system. That is what a living smart built environment is. Moving on then, in terms of smart homes, it means that, what we find so often is that in many so-called smart homes, the control of the system is open to consumers, the user or the owner, but in reality it's never theirs. It belongs to the hub controller. The user can continue to use it as long as the vendor allows access to it and maintains and supports it. As soon as the vendor pulls the support, it's no longer the users. They cannot do anything with it. I mean, if we look last week, there was a outage in Amazon Web Services, and so many smart devices could not be used in the home. For example, some of the doorbell systems did not work because the Amazon Web Services were down, and because they relied on those sorts of things. Now imagine it wasn't an accident like it was last week, things went wrong. Imagine if the user, if the vendor pulled support. That's the sort of thing we're talking about. So while the vendor controls that environment, in reality I would question as to how smart it actually is. From the user's perspective, it can be really, really smart, but while the vendor controls it, I think it's a bit limited in terms of the definition. So the benefits provided not under the consumer control, but with the service provider of the hub. That's a fact. Data analysis is often for the vendor advantage and benefit. The benefits there are usually at low level of gains to the consumer, and the vendor in many cases gains more from the data analysis than any single user by having the system. It's a bit like all of us having Android phones or Apple phones. What we find is that the platform owners gain much more collectively from all of us using the system. That's an example. So the supplier is looking to develop other revenue models based on data collected from its users who supposedly own the system. And the chances are, yes, we theoretically have paid for something in a smart home, but that doesn't mean that that's the end of the amount of money that the vendor is going to make from it. So if the technology relies on the internet for control, my view is it's not really that smart, because if you lose internet connectivity, you have no control to your device. You have no control to what you're trying to control. So if you couldn't, if in terms of what happened last week when Amazon Web Services went down, if people couldn't open their front door using the controls that they supposedly have got, how smart is that? And is what I'm questioning. So in terms of smart buildings, many current smart buildings, there are levels of automation. There is intelligence in many smart buildings, but mainly I think it's smoke and mirrors. Intelligence in single systems does not necessarily equal intelligence in each or all systems, or intelligence at the system of systems level. Intelligence creation must be within customer control to develop, not by the vendor to fake, which I've seen so often in events. The more processing that needs to be done at the edge or jointly with cloud services under the control of the consumer or the owner, the better it is. System integration needs to be at the forefront, not an afterthought for data collection. And that's what we've seen so often, where the integration is really as a way of getting more data from the customer by the vendor, as opposed to, because that's what should have been done right at the forefront of when the technology or service was designed. Without cybersecurity baked in, the building is just another system, nothing more than that. And without the integration of a security operations center or response center, all we've got is a building which is another vulnerable system. It's not actually a smart building. When it comes to smart cities, many of the smart cities today we've seen, in my view, is that people tend to think, to be called a smart city, all you need to do is to think strategically as to how you're going to integrate them and how our citizens are going to benefit. But what they tend to do, that's the high level thinking, but what they tend to do is basically relying quite often on installing CCTV systems to be called a smart city. And basically my view is that, no matter how many innovations you have in a surveillance technology, on its own, it's nothing more than an infrastructure project. And this applies for any technology and any infrastructure. You know, just because London has got Transport for London doesn't necessarily make London a smart city. It makes London a city that's got smart infrastructure. For London to be called a smart city, it needs all these different infrastructures, whichever infrastructures it chooses, to work in an integrated way, not for them to work separately to be called a smart city. The percentage of benefits for any surveillance in any city must be weighed towards the citizen, not towards state control. Again, around the world, I've seen cities called smart cities where really and truly, you know, they're just surveillance systems. And there may be smart surveillance systems in some way, shape, form or another, but they're not actually geared towards the citizen. Citizen control or benefit must not rely entirely on the latest personal mobile devices, because that is not smart city. That is a city that forces citizens to use smart devices. Okay, so maturity levels. Let's have a quick look at those. But before we get into the 1 to 4, let's look at the -1 and the 0. And in terms of the -1 to the 0, let's look at past technologies where we've had environments that may or may not use any number of non-integrated systems controlled by an application. This is the state of many environments of yesteryear. That's the -1. The 0 is environments that use smart technologies, and this is the current state of some or many environments today, where basically what you've got is without integrating devices or systems, or only integrating a few of them, you've got a variety, but they're not necessarily integrated. Then the benefits are focused more on a single or a few user groups. Then there is no unified management control system. So they're all separate, they're all controlled separately. There isn't a single unified system for them. Next, that the response is user provided. It relies so much on user providing lots of input to be able to get a response back, and that's about it. Next, we're going to look at the level 1 to 4. And here we've got, first of all, environments that meet the definition criteria that I've covered already, and have utilized the data to react to the environment. So, system provided automation response, that's the level 1, so it's reactive. Next, we've got environments that meet the definition criteria and have utilized the data to adapt to the environment, so that we've got system provided adaptation now. The third level is environments that meet the definition criteria and have utilized the data to predict responses to the environment. This is what we call smart environments, because they're predicting. Now the highest level, level 4, is environments that meet the definition criteria and have utilized the data to take responsible choices on behalf of those users using that environment. So that's a responsible environment. Now next, in terms of some of what we've got, the thinking there, not entirely, but it comes from a paper that was produced in 2014 by some lecturers in Sheffield University. I had a chance to have a conversation with Stephen Beck last year, and the paper that they wrote, What is a Smart Building, doesn't actually provide a definition, because they felt that at that time they couldn't come up with a definition which wouldn't be limiting. And I totally get that, but I think now we're in a slightly different phase, and so we're in a position where I believe that the definition we've come up with is good and it's right. However, in terms of this paper, what they do present, and it's quite important, is that they've got the different levels of you know, the buildings at the top there, and then on the left hand side there is the sort of attributes that they've picked out, and on the right that's all in white. So their paper covered all the things that are in white. What we've added here is on the right in blue, and we added this in a white paper a couple of years ago. This was my colleague James Willison and myself, and we added the building concierge. This is that responsible approach that was mentioned at the high level in the previous slide. And we've moved from control flow at one end from being reactive, and at the other end in terms of being responsible, and control and efficiency moving from system and data integration to actual user-centric data and inputs. Yeah. So these are the details. I'm not going to go into them right now, but that's the starting point. What we did with this was we expanded it. We decided to expand it a bit further. And what we did was we kept the titles at the top the same, and on the left hand side we threw in, again from some of the other definitions that are out there, and what we've included now is stakeholder benefits, automation and intelligence, decision making point, cybersecurity view and a privacy view. And at the one hand, for example, in terms of shareholder benefits, the benefits may not extend beyond a type of device and the management system. Through to the other end, where the stakeholder benefits use and historical data, and there's a sophisticated rule set which enable ultimate use of automation. So the stakeholders benefit in lots and lots of ways of automating things in a way where they're not just a handful of triggers, but they're a sophisticated set of rules. Next, in terms of automation intelligence, you've got device and system-based rules. Through to the other end, again, copied similar, where you've got the use of everything, every bit of data that's internal, external, and so on. In terms of decision-making point, at the one end, you've got the device and system, and at the other end, you've got where data and the decisions could be taken at the edge, it could be taken at a system of systems, it could be multiple data sources, it could be data that comes from out of the environment, into the environment, or within the environment. It could be a whole range of things. Basically, the idea is that the intelligence will determine what data it needs to make what sort of decisions appropriately. The cybersecurity view, at one end you've got no development controls, no protection controls, and at the other end data is accessed and controlled according to the requirements. So who accesses data, who doesn't, and who sees it, where the data comes from, all of those things are done in a controlled set of rules that do respect cybersecurity for the environment. On the privacy view, you've got at the one end no concept, no controls, and at the other end where data is accessed and controlled according to the requirements. Again, yes, in that right hand column, what we've added there, it applies wider, but at the lower levels it's very how can I say, it's very specific. We just made sure that up the right hand side, the concierge part, where you're beginning to merge things together and share some of the benefits and some of the resources and some of the actual end results and outcomes that you're looking for. And at the bottom you can see that over time that's the sort of building or environment that is going to be sort of the sort of environment that we will be living and using. So in summary, smart built environment is not smart based on the utilization of any single or small number of technologies, systems or infrastructures. The use of data by a smart built environment is beyond that which is collected by a single or small number of technologies, systems or infrastructures to provide real benefits based on real intelligence. The real benefits from real intelligence will come from multiple sources, including ad hoc artificial intelligence, which means you can choose any one you want to, or multiple artificial intelligence. So for CCTV systems, you might have one artificial intelligence which is really good at night and cameras which are in the dark, another one for during the daytime. You might have, as we've seen, cameras which have picked out and have been biased against black, Asian people and women and so on. So you might have special type of AI that will select a particular type of audience and then go out and use that appropriate one. Machine learning, big data analyses, edge computing, user generated data, all of these things rather than a single vendor solution. So the vendor is only providing the hardware and part of the system. All the intelligence that we're looking for actually comes from lots and lots of sources, and that vendor may just be one of those sources of artificial intelligence or something else or whatever else it might be. But also it does mean that data and data formats must be standardized for use, because if they're not open standards, then you're not able to benefit from all of that. The integrity, confidentiality, availability of any data in the environment is maintained such that there are no or very limited opportunities for poisoning data to affect the overall benefits and outcomes, which means data models and threat models must be taken into account at a very early stage to ensure that nobody is able to abuse the system in any way, shape or form enough to affect the whole of the system or any particular stakeholder group. Smart built environments are actually the outcomes of multiple technologies mixed with multiple sources of relevant data, which are used to create multiple benefits for multiple stakeholders without compromising them, the data, or their devices or technologies. And all this matters for a whole range of reasons. And the thing is, knowing the maturity level enables stakeholders to take appropriate actions. And these are not all stakeholders, but the appropriate ones to take those sorts of appropriate actions. And the greater the benefit objectives of a particular stakeholder group, the greater the investment in the appropriate open technologies that they're going to have to put in. Data requirements and standardization have to come early. There cannot be an afterthought when vendors have already made the unchangeable decisions. All of that has to be thought of beforehand. So if you're speaking to vendors right now and they haven't understood how data needs to be standardized in the right way, well, I would start speaking to them and or other vendors about what they're doing there. Cybersecurity in the smart built environment must be by design and default in every component, device, system, infrastructure. That's why it matters, and including data models and so on. So it matters because the use of ESRM principles is mandatory. It's not an option, as is having a security operations center. So smart built environments have that. They don't exclude it and they don't include it as an afterthought. It's there right from the start. So technology purchasing decisions must be towards open systems and open models, not closed systems and proprietary approaches and models. Also, awareness of cybersecurity and privacy issues isn't enough. These have to be standardized, rigorous, in terms of rigorous processes from the inception of the project and throughout the lifespan of the project, not just at one point of it, or either at the early or middle or whatever. It's got to be throughout the whole of the lifespan of the project. New threat models must be reviewed regularly throughout the lifespan of the environment. Occupier, users, citizens' participation must start early and continue during the lifespan of the environment. Again, it cannot be an afterthought because technology changes, people change, their needs change, everything changes. And what citizens might want out of a system or an environment at an early stage of the lifespan of the environment may be completely different from a later stage. The necessary ecosystems have to be planned for to achieve effective stakeholder engagement and benefits. Again, it can't be an afterthought. And smart built environments will involve, definitely they'll evolve to living systems of not just systems themselves, but systems of systems requiring ongoing investment to improve stakeholder benefits over the lifespan of the whole environment. If it's not secure, it's not smart. So if you've got any questions, happy to answer them now.